Okay. So, good afternoon, everybody. At least for me here in Colorado, it's the afternoon. I assume folks will be showing up from all over the place, so we'll do the usual dance about times of day and all that sort of thing. Um, I appreciate your time and attention for an electronics BOF today. Um, this has become sort of a tradition at DebConf every year for us to talk about the state of the packaging of tools for electronic design and manufacturing that are in Debian. I have just a couple of slides here to sort of explain the purpose of the BOF and talk a little bit about the Debian Electronics team, and then I'll finish by speaking briefly about the current state of the Lepton EDA schematic capture toolset and PCB R&D printed circuit board design toolset, which are the two primary things that I personally maintain within the electronics group. Um, of the folks that I know for sure will be here, I'm also expecting Keith Packard, who, let's see, can I get this to actually, oh, I have to do it over here, of course. Right. So the purpose, what we'll try to do today is talk a little bit about what the current state of various pieces of software or some of the progress that's been made in the team in the last year. I expect to spend most of this session in doing question and answer stuff. And in particular, it would be lovely to come out of this session with ideas about how we can do an even better job of maintaining electronics tools in Debian. This team is one of several defined teams within Debian, and as a result, there is a wiki page for electronics packagers within Debian. So, I mean, what is Debian Electronics? Well, first of all, it's a team of people maintaining packages, but those packages are packages that are used by electronics developers, including tools that are used for the development of embedded system software, because a lot of people developing electronics today have to develop little bits of software to run on that electronics. The kinds of tools that are included in this suite are things like schematic capture, printed circuit board design, circuit and electromagnetic and radio frequency simulators, tools for the development of field programmable gate arrays and application-specific ICs, cross compilers and libraries, which include some special cases like the tools for Arduino. And then there are a number of embedded target debugging tools, things like OpenOCD, that allow us to plug little dongles into the bits of electronics we're designing and debug the software that runs on them. And we're really blessed in Debian by a fairly rich set of tools. Keith and I run a little business called Altus Metrum, where we develop open hardware and open source avionics for the high power model rocketry hobby. And all of our products are completely designed, manufactured, produced, and delivered with tools that are packaged in Debian, which is really cool. So most of the team's work happens in a group on Salsa. I took a look this morning, and there are 27 current members of the group, which is way up from a couple of years ago when it was more like 15. And there are now something like 55 source packages in the Salsa repository that generate a lot of different binary packages. So there's a lot of stuff there. There are always more interesting tools that could be added, and we're certainly happy to have help developing and maintaining these various packages and other stuff. So let me talk just briefly about the current state of what's happening in the tool chains that I spend the most time working on. The first of those is Lepton EDA. This is a fork of the old GPL EDA toolset, GEDA or Ghdl. The current state is sort of interesting in that Lepton EDA has really, I think, sort of become the focal point for further development by people who are using this particular tool set. This Lepton EDA provides schematic capture and related tools. 1.9.13 was released with Bullseye. That version is just fine. 1.9.16 is currently unstable, and it's what I'm using pretty much every day. It still retains full file format compatibility with the GEDA toolset, so bringing things forward is quite easy. Because the Lepton EDA folks have been gradually refactoring and improving the code base in a lot of ways, If you have written little scheme fragments to customize behaviors, generate different output file formats, that sort of thing, you may have a little bit of work to do to bring those up to compatibility with the APIs in Lepton EDA, but the fundamental file formats are unchanged. And as I say, I'm using that tool myself almost every day. The GEDA tools, by the way, still exist, but are unmaintained in unstable. The package name is Ghdl-GAF. That was not considered suitable for release with Bullseye, so you can find it in old stable or in unstable, but not in stable. PCB-R&D began as a fork of the PCB tool that's associated with GEDA. The PCB tool, by the way, is still around in Debian. I don't believe anybody's actively maintaining that package, but it does exist in unstable, was released in Bullseye. And it has various bugs, but they are possible to work around. And I think there's still some people doing useful things with it. PCB-R&D started as a fork by Tibor Palinkas in Budapest, and it has now evolved so far beyond what PCB ever was. It's the printed circuit board design tool that I'm currently using for all of the things that I design. I'm really quite pleased with it. Version 2.3.1 was released with Bullseye. That's a pretty reasonable version. The 2.4.0 that's currently unstable is what I'm using all the time. There has been a recent release of a new version 3.0.0, but for this time, with this version for the first time, there's been a refactoring of the source code so that there's now a distinct, separate librd. R&D stands for ringdove these days, by the way. So this is a library that's been factored out from PCB R&D that provides lots of capabilities that will be used by other tools that are going to be added to the ringdove tool suite. And right now, librd 3.0.0 is stuck in new, waiting to be processed out of there. Once that makes it into unstable, I will package and upload 3.0.0. The good news is that for day-to-day use, 2.4.0 is just fine. 3.0.0's primary claim to fame is that transition to the separate library functionality, though there's some new capabilities, some new I/O compatibility with other tools and so forth that's quite interesting. And then I'll also mention that within that suite, the first additional tool that will use librd is called camv-rnd. This is a CAM file viewer. You can think of it as a replacement for Garbee. I am not personally using it yet because I try to only run the code that I've actually packaged and uploaded. I did build camv-rnd. It's uploaded. It's also sitting in new. But until it and librd make it out of new, I'm kind of making a point of not using them. That's probably idiotic, but it's the way I think. So with that, I'm going to stop screen sharing. We'll see who else is around. And at this point, I'll be more than happy to transition to somebody else. Does Keith shine up?
Sorry, we're still the only ones here. Okay, I can say a few things about GHDL then.
Sure.
I'm maintaining GHDL. I managed to get the version 1.0 release into Debian stable, so this is now released. One nice thing about that since the last stable Debian release is that the IEEE libraries were relicensed under Apache 2.0, which means that they are now DFSG free. So I switched over from the GHDL replacement of the libraries to the official IEEE VHDL libraries, which means we get VHDL 2008 support, which is pretty great. That wasn't available before unless you used the non-free libraries. So this is a great step forward. Right now, what's the next thing that's going on with the package is, there's again a few one release critical bug that has appeared. New auto conversion is incompatible. I'll look into that. LLVM 12 needs to be made compatible, or it probably already is. Need to unlock it to compile for LLVM 12 as the compiler. Something I didn't manage to get during the freeze is the additional Python package that it now also offers, which is used by really just one tool, I think, that is Ghdl ls, which can apparently can be integrated into text editors and provides semantic parsing, I suppose. Other thing is external libraries that need to be compiled. I wanted to create a framework for that, which doesn't exist yet. Upstream has a few scripts, which is nice for compiling your external libraries into Ghdl for when you've installed it locally, but not very suitable for distro installed packages. That's something I'm going to work on. But yeah, Bhdl 2008 support is pretty nice to have, which we have now.
That's very cool. Are you actually using that to build any physical things right now, or are you just fascinated by the software?
I have this PDP-8 replica project, and I've been using Ghdl for that. And actually, the Bhdl 2008 support in Ghdl, it's not complete, but the problem is maybe that it's too complete because you develop something using 2008 features. Test it, works. Then you try to get it into the Intel Quartus, and it refuses because it doesn't support as much Bhdl 2008 as Ghdl does.
Oh, wow.
I don't know if there's overlap or that Quartus supports something that Ghdl doesn't, but the big two, which is now Intel, formerly Altera, and Xilinx, they're not that great with supporting Bhdl. So I guess whatever you have in Ghdl as Bhdl 2008 support will be more than enough if you're targeting FPGA.
Okay. Well, thanks very much. That's really interesting, and I'm really glad that you've been working on that stuff. It's awesome. I see Keith has managed to find us. Hey, Keith.
Hello, Bdale. I haven't chatted with you for over an hour.
Yeah, we do get involved in various things, don't we? So you were going to tell us a little bit about Picolibsee, sort of what it is, how it fits in the world, what its current state is, and so forth.
Yeah, I'll mostly do status. I have a 40-minute presentation I could slide in here if you want, but it doesn't seem appropriate for a BOF. Let's see.
So if that presentation or a video of it somewhere else is online or something, pointing to that could be cool.
Yeah, it will be. It will be in about a week. It's being presented at Libra Lenaro Connect next week. So
oh, cool.
I'll provide links for that.
So I get a little thematic preview, if not the actual content.
Yeah. I'm just going to tell you what Picolibsee is, and then and then I'll do. Does this work?
Yes.
Okay. So for those of you who do embedded development, who have used 32 and 64-bit microcontrollers, you've probably looked in vain for a decent C library. I hope to come to your rescue. So Picolibsee is built from bits of newlib and bits of the AVR libc with a whole bunch of changes. Let me get some numbers down here to kind of show you what it can do. Here is, I'll show you the program. Here's the program. It's a huge program that prints a floating point number. And here are the sizes with various different libraries. 3 versions of Picolibsee. with 64-bit float support, 32-bit float support, and integer-only support. And then kind of the competition, newlib, in its float and integer form. So the neat thing about Picolibsee is you get full, accurate 64-bit floating point I/O in about the same size as newlib can manage to do integers, except it doesn't use any RAM. So that's pretty cool. If any of you have played with little RTOSes, here's one I found in the last year that is interesting to me. It's a Riot. It's a LGPL real-time IoT operating system. It's got really nice POSIX APIs for applications, so you can kind of port your POSIX-ish code in here. And they adopted Picolibsee and have been using it quite a bit. They called me in in August 2020 to kind of help out with some merging stuff, and we got it all merged, and it's available now in Riot. So if you're playing with RTOSes, that's not a bad one to look at. Let's see, I have some recent changes in Picolibsee. Surely that's here somewhere. I had that slide. There we go. Recent Picolibsee work. Things I've done in the last couple of months. I finally just merged the math library into the C library. I wanted to use the math library from some C library functions, so I just smashed them together. It's a little more convenient for application developers now. You don't have to remember to add the math library. I finally added hex format float support. So you can now print your floating point numbers in hexadecimal format, which is an odd C99 feature, C11 feature. I don't remember when it came in. And as of this week, Picolibsee builds cleanly with the W-extra compiler flag, which was quite a lot of work. The newlib code in particular is so old. There are still KNR declarations in this stuff. And as of a couple of weeks ago, you can build C++ applications with Picolibsee and do embedded development with C++, including even exception handling. Oh my goodness, it's really amazing. And that's what I've got on Picolibsee. I've got, oddly, 36 more slides if you want to hear more about it, but that's kind of the interesting things going on there. It is in Bookworm, current stable at version 1.51, 1.5.1, with support for 32-bit ARM, 64-bit ARM, the Extensa LX106, and RISC-V. Some really cool thing that happened in the last year is that my friend Mike Hartel, who's a silicon designer at Intel, gave me bare metal support for x86, that take an x86 processor and get it into 32-bit mode or 64-bit mode of running bare metal applications. So if you're excited about doing bare metal development on x86 processors, I have a library for you. And with that, I'll let it go back to Bdale.
Okay, great. Thanks, Keith. We've certainly been happily using Picolibsee for some of the things that we're shipping to customers now for a while, which has been a pleasant consequence of Keith's work on this, and seems to work great for us, so that's cool. So it looks like Paul Flaherty's joined us. Paul, how are you today?
I'm doing great. So I had a couple questions about, first quick question is, do you have a link to this presentation so I could reference it?
Yes, I'll have a link for that presentation once it's been put up at Linaro Connect, and I'm also giving it in a couple of weeks at the Linux Foundation Embedded Linux Summit. I think I can probably give the text of the presentation right now, and it's really complete.
I'm not going to Linaro Connect.
Yeah. What I'm saying is I think I can actually publish a PDF of the presentation that has all of the text on the slides, as well as all of the text in the presentation. So you can actually read the whole presentation that I'll be giving, which is probably, yeah, I'm glad you found a workaround.
Yeah, we've all stumbled over things like that before, and it's super frustrating, but until and unless all the software in the world works perfectly, we just have to, do what we have to do to make things happen.
Bdale's Utopia.
Well, yes, we'll just call it that and walk away. Don Knuth. grabbed me around the arm once at a conference and asked me if folks in the free and open source software world had yet figured out how to know when a program was done. And it led to a really fascinating conversation where the obvious answer was, what does it mean for software to be done?
Well, and you've removed all the bugs, Bdale.
Yeah, right. Well, the interesting consequence of that conversation was a realization that he really liked the notion that one might specify, a particular sort of set of needs and behaviors and sort of go write a piece of software that did just that, and then try to drive the bug count to zero. And of course, when was the last time we successfully avoided adding a new feature to some program that we depend on? Yeah.
And no, Bdale, you drive the bug count to zero by removing all of the software.
Yes, you've done more of that than many of us, and we thank you for it, Keith.
The empty set of software has no bugs other than missing features.
That which is not in orbit will not fail in orbit.
I actually I modified that quote for use in my presentation.
Oh, really?
Yeah, when you don't put malloc in orbit, malloc will not fail in orbit.
There you go. There you go. There you go. Okay. All right. Well, I think we're very well and truly sort of to the end of the useful time that we can spend on this BOF. I want to thank everybody that's here for taking the time to come participate. Really appreciate it. We'll look forward to doing this again sometime soon, perhaps the next time there's a DebConf.
Maybe face-to-face someday.
Wouldn't that be awesome?
Yeah, I wish that. I wish it was in person, just like I said in my loop-de-loop video.
Yep. Okay.
Yep.
All right. Well,
Okay.
thanks, everybody.
Thanks.
Thanks.